Okay, so here is the Unit 2 wrap-up. Okay, so the first thing you need to be able to do is know everything about a position graph. All right, so I'm just going to sketch one. X meters. All right, so 2, 4, 6, 8, 10. Okay, and then 0, -2, -4, -6. Okay, so you could have negatives if you want. Okay. All right, so the first thing you're going to do is let's just make a nice, simple, easy graph. Okay, I'm just going to kind of fake a little graph here. So like 2, 0, 2, 1, 4, 2, 6, whatever, just to make it like nice and easy. Okay. All right, so then we're going to pick 2 points. Okay. 0, 2, and 4, 10. Okay. All right, and then when you find the slope, you're going to do y2 minus y1 over x2 minus x1. So that's going to be 10 minus 2. Okay, so, oops, let me pick a different color. Okay, so this is going to be maybe like my x1, y1, x2, y2. Okay, so 10 minus 2, and that's meters, right? Because that's in the x direction. I mean, sorry, in the y direction. And then 4 minus 0 seconds. So 8 meters in 4 seconds is going to be a speed of 2 meters per second. Okay, right? So you want to divide that out into a decimal. Okay, this one came out nice and clean, but it doesn't always. Okay, right? So this is the velocity, and this means for every 1 second, the position increases, because it's positive, by 2 meters. Okay, all right, so here's a skill, right? Finding the velocity. Here's a skill. I don't want to number them. I'm just going to put a star. Okay, writing the for every statement. We've seen that a couple times. All right, and then we want to be able to write the whole math model. So remember, it's going to look like this. Final position equals VT plus XI. Okay, and then the XF and the T are going to be the variables. So I'm going to plug in my velocity here, 2 meters per second, times the time, right? Because these are my variables. Those stay. Plus, I can look and see where it starts, which is 2 meters. Okay, so that would be what my math model would look like. Okay, so that's another skill you need to be able to do is write the math model. All right. Okay, another skill is predicting. Okay, and all these skills we're going to put together next week into the final project. All right, so let's say what position is the object at time equals, let's just say 5 seconds, okay, or whatever. Okay, I'm keeping the numbers really easy for the example, all right? So if you want to make the prediction, what you do is you'd have your equation, all right? And then I can plug this time in right here because I know how many seconds it is. All right, so the final is going to be 2 meters per second times 5 seconds. I'm going to plug that in. Plus 2 meters. 2 meters per second times 5 seconds is going to be 10 meters plus 2 meters, which is going to be 12 meters. Okay, so that's the position, all right? So remember, position is on the number line. Okay, so the position is 12 meters, all right? But if it asked me for the displacement, that's how far, okay? So I could do the final minus the initial, right? Because you can see this graph actually goes to 5 seconds. Okay, that would be, whoops, it's a little bit off. That would be the next point, okay? So if I look at the graph, right, final would be, let's see, in 5 seconds, 12 meters minus the initial 2 meters. Okay, the displacement would be positive 10, okay? And I can see that here because, see, that's this part of the equation, right? How fast it was going times the time, that tells me how far it went, all right? And then if I want to know the actual position, I could add on that initial starting point, okay? So you might need to find the displacement from the position graph, right? And remembering if it's like something like whatever, okay, you only need to look at the initial and the final to see what it is. All right, it doesn't matter whatever kind of garbage happens in the middle, who cares? You're just doing final minus initial. Okay, so that's another skill that you might need to do, is finding the displacement. There's another one. All right. Let's see, what else can we see on a position graph? Okay, remember, on a position graph, positive slopes are moving in the positive direction. Negative slopes are moving in the negative direction. Okay, so you should be able to kind of relatively compare what's happening. Okay, and if this were two different objects, like I know we're very fond of saying red and blue. Ooh, SI colors, why did we pick that? Should have picked green and blue. Sounds stupid. All right. This here is where and when they meet. Okay, so they meet at a time t and at a position x. Okay, so that's going to be important for some people, depending on which summative you pick next week. Okay, you might need to find that meeting point. Okay, so that's another thing that you could do. All right, if I'm looking at those graphs, right, I could see like A, B, right? A is slower, B is faster because the slope is steeper. Shallower, shallower, more shallow. All right, so that's another thing that you can see from the position graph. Okay, all right, so that's the main things that you're going to look at on the position graph. Okay, you need to be able to find the slope, write the for every statement for the slope. Okay, write the math model from the graph. All right, maybe make some predictions, right? Like where and when is the object, or where is the object going to be at a certain time? Okay, or find the displacement, the final minus initial. All right, here's another example, how fast, and the direction by looking at the slopes. Okay, let's see, is there anything else on position graph you might need to know? And then, of course, write the description, right? But I think you can probably do that. Okay, all right, the other thing that we learned was velocity graphs. Okay, and the main thing you need to be able to do is just draw it. Okay, so if I have a position graph, right, say it looks, oh, that's not good. Let me make that a little bit more drastic. Okay, say it looks like this. Okay, all right, I need to be able to draw from this the velocity graph. I use green this time, see, you're welcome. Okay, so I have kind of like these three different things happening. Okay, in the first segment, this is a positive velocity. Okay, and it's relatively fast compared to the second one. Okay, so that would be a line, you know, like up here somewhere. You know, and say if this is 3 meters per second, then, oops, then this would happen at 3 meters per second. Okay. All right, and then this second piece, that's a lesser slope. Maybe that's, say that's maybe has a slope of -2. I don't know what it has. Okay, then I would see that 1, 2, 3, 1, 2, 3, right? I would see that a little bit closer to the line, right? So do you see how that is further than that? Okay, that means the second one is a little bit slower. Okay, and that would happen for a certain amount of time. All right, and then a flat line on the position graph just corresponds, okay, to a flat 0 line on the velocity because it's not even moving. Okay, all right, so you might need to be able to draw the velocity graph. That's something that you need to be able to do. Okay, and just remember the slope here becomes this number here, okay, where it's at. All right. And then the last thing that you need to be able to do is find the displacement. Okay, and that's where we're going to use these shaded areas. Okay, so let's just say this is 1, 2, 3, 4 seconds, 5, 6, 7, whatever. Let's just pretend. Okay, all right. So the area of this box, 4 times 3. Okay, so that would be a plus 12, right? Because it's moving in a positive direction. And then here, 3 times -2 would be a -6. Okay, so the total displacement would be plus 12 plus -6 meters. So that would be a total displacement of positive 6. Oh, that's not right. 3. Oh, yeah, it is. It is. Oh, I'm thinking, okay, because it started here. Okay, so, right, so from here to here, if this were the case, this would be 0. And this would be 6, right? It would have gone a total of positive 6. All right. So that's the required skills, right? Also, remember, if you're kind of going on the little bit more advanced version, you could do the distance, which would just be the absolute values, okay? Right, so that would be a distance of 18, you know, and then the numbers can get a little trickier, whatever. Okay, but that's the basics of what you need to know, all right? For the velocity graph and the position graph. Okay, it's a harder skill to start with the velocity graph and draw the position graph. That's a tougher skill. Okay, so that's kind of like on the medium spicy level. We won't actually make you do that like on a test or anything or on a project. Okay, all right, so there is your wrap-up notes.